Hello everyone. Today we'll speak about fine-tuning large language models. What is this fine-tuning is? We'll see about it. Before that, let me introduce myself. My name is AiSPRY. I work as a associate data scientist at AiSPRY. So, what is this fine-tuning large language models is about? We'll see about it. What is fine-tuning is? Yes. So fine-tuning is a specialized training process where a pre-trained LLM is updated with a smaller task-specific data set to improve performance on a particular domain or function. So let us understand this with the analogy. Okay, let us take an example of driving a car, how it works. Along with the example, we will see what is the difference between pre-training. We will also see what is fine-tuning and what is hyperparameter tuning. Hyperparameter tuning. Because most of you will have the confusion with this, right? What is this pre-training? What is this fine-tuning? And what is this hyperparameter tuning? And how these three differ from each other? They all sound the same, right? How do they differ from each other? So let us understand that. How does they differ from each other? Consider you want to drive a car. You want to learn to drive a car, basically. So what does pre-training means? Basically, pre-training means you're learning from scratch. You're learning from scratch. You learn to drive from the scratch. Okay, maybe over there you will learn some general driving skills. Okay, before driving on the real road. Okay, before taking your vehicle to the road, you'll learn some few initial things like what are the different signboard says, or what is accelerator, what is the brake, where is the clutch, how to put the gear, how to rotate the steering, or where is the headlight, all those things, all those few stuffs which you need to know before you start the driving. Correct? So that is nothing but your pre-training. That is nothing but your pre-training. Okay? Once you finish, understand this general instructions, okay, you can drive in the specific environments. Correct? You can drive in the road maybe, but you might struggle to drive in a hill space maybe. Correct? Maybe off-roading. You might have heard of it, off-roading. Correct? You might struggle to drive in this space. Correct? Maybe you might have seen few competitions and all, how tough they will be while driving the vehicles. Correct? So to drive in this off-roading and all, they need some special techniques to understand, some special skills they need to learn, all those things, right? That is nothing but your fine-tuning. Okay? Fine-tuning is like you already know how to drive, but you're taking additional training. You already know how to drive. Correct? You know all the basic driving, you know all the basic driving techniques. You are good driving in when it comes to the normal road, but when it comes to the off-roading, you may not be not that good, right? So what do? You take some additional training to drive when it comes to the off-roading. Correct? Not only the off-roading, any other specific driving conditions. Okay, any other specific driving condition. Maybe for the racing, using how to control a sports car, which is you need to have a special skill to control the sports car and all. So at that time, you need some additional training. Correct? So that is nothing but your fine tuning. Correct? You already know what you're doing. That is your driving. Correct? But you are adding few extra skills extra skills so that you can drive in a particular conditions. Now let us see what is this hyperparameter tuning then. What is this hyperparameter tuning? Basically, hyperparameter tuning is like adjusting few car settings, okay, so that you drive you drive smoothly. Maybe you're checking the pressure in the tires or air recall in tire, correct? Um, Checking the oil, correct? Checking, do you have the fuel in your vehicle or not, correct? Basically, you're adjusting this, okay? If it is not proper, if the pressure or air is not proper, you will adjust it. You have some particular machineries to do that, right? So you just try to adjust it. If there is a, you know, if there is no oil in the engine, and if there is no proper supply of oil to the engine and all, you try to adjust it. You will put some extra oil and all, correct? So that is nothing but hyperparameter tuning. Basically, you're adjusting few already existing parameters. You're adjusting already exist your parameters, correct? So hyperparameter tuning, it will not change the model's knowledge. Okay, it will not change your model just because you increase the pressure in the tire of a car. It will not make your car from some one brand. Maybe if you consider from Swift, if you just adjust the pressure in the car, it will not turn your Swift to SUV. Correct? It will not turn it. Correct? It just makes a additional changes in the Swift itself. Correct? So hyperparameter will not change your entire model's knowledge, but it optimizes how it learns. It basically optimizes how it learns. Okay, when I have to give a LLM example itself, consider your chat GPT. Consider your chat GPT, correct? So what does pre-training in that? Chat GPT is already pre-trained on all the general cases, whatever the use cases or whatever the things are present over the internet, it have learned everything. It have learned everything. But when it comes to a particular job, maybe I want to use the same chat GPT for the particular medical domain, for a particular medical domain, okay, medical domain where it needs to particularly focus on medical protocols or medical policies or medical procedures, correct? So at that time, what I'll do, I'll add additional data or additional medical documents to my chat GPT itself, okay, my chat GPT model, I will add this information. What is this hyperparameter tuning it means? Basically, you will have few parameters. You can set it over there. You have epochs over there, correct? You have batch size. All these are multiple parameters are there. Basically, based on this parameters, it is told that how well your model is learned about the data. Model has learned about the data. So your hyperparameter, if you tune this hyperparameter based on it, which it will trained on your data. Okay, so this is the basic difference between your pre-training, fine-tuning, and the hyperparameter. Still, you must be a bit confused between fine-tuning and pre-training. How does it differ from each other? At the end of the day, it does almost a similar work, right? How does they differ from each other? Consider consider pre-training as consider pre-training as going to university going to university and getting a degree from there getting a degree from there correct? You're going to university where you are taught with all the similar subjects what other students also have been taught, correct? What does fine tuning means? Fine tuning basically means by putting your extra time, you're learning some new specific technology, or some you're learning about specific software, maybe by doing some specialized certifications, by doing some certification maybe in online. You have plenty of the platforms, right, where you can learn extra things, learn extra added things along with your university subjects, right? So that is nothing but your fine tuning. That is nothing but your fine tuning, correct? So this is a basic example of the to see the difference between pre-training and fine tuning. Okay. So now let us see, since we understood what is the difference between pre-training and fine-tuning, let us see more about fine-tuning. Why this fine-tuning is important? Why do I have even need to do this? Okay, what are the benefits of using the fine-tuning? I can just go with the chat GPT, right? Why do I need to, specifically train on the medical data or any other kind of data? Why do I need to do this? So, fine tuning enhances an LLM's specific performance. Specific performance is being enhanced, making it more accurate, faster, and reliable in a specific applications. So, what happens is whenever you ask a specific domain question, maybe related to a medical domain, you ask about some policies and all. You ask about some policies or some protocols. What happens? Your ChatGPT will go to what it will extract. It will extract general policies or general protocols which are being followed out there by everyone. It is not specified to your particular department, maybe, correct? A specialized department, maybe it is a, you know, orthopedic department or gynecology department. It may not be specific from that particular department, correct? At that time, what happens? If you're fine tuning your model with the specific details of that particular procedures which is followed by your uh, hospital, maybe at that time it will give you the relevant results, very relevant, much accurate, so that you should not go wrong at any point of time. Okay, so that is one of the major benefit of the fine tuning LLMs basically, correct? So now let us see in specific what are the advantages we have. So improved task specific performance. Consider, let us take three examples over here. Let us take examples of three industries over here, correct? Legal AI. We have a model called as Legal BERT. We have a model called as Legal BERT. When you ask a normal BERT model, what happens? It gives you a generalized, if there is some sort of criminal cases going on. Okay, consider some sort of criminal cases going on. What happens when you ask general LLM models? Correct, maybe BERT, it could be ChatGPT, or it could be your Gemini AI, correct? So it will give a basic rules which are being followed by everyone, correct? But what happens? You want a particular detail on a specified, a special case, maybe a special case is going on. You want a specific, what are the procedures followed it, or what are the charges will be applied on that particular case, or what type of verdict might the um, accused get, or the, sorry, yeah, accused get, right? So all these things won't be told by your general LLM models, which is being told by your legal BERT. correct? So similar to this, we have other models when it comes to healthcare AI as well. We have something called as healthcare AI when it comes to AI in the field of healthcare or maybe hospitals, correct? We have something called as BioBird. In this specific way, for a particular disease, what kind of diagnosis may be followed, which you may not find in your general general models, correct? General LLM models. And when it comes to e-commerce also, you have, or if I say I have, when it comes to finance, we have something called as Finbird. When it comes to finance, we have something called as Finbird. Basically, by looking at your portfolio, it will clearly say what kind of how much return you can expect, or is there any loss you're going to face, or if you invest in this particular company, what is the returns you will get after 3 years or after 5 years, what is it? Okay, that information will be given to you. So it will basically improve the task. Okay, accuracy basically it will improve the accuracy by being task specific. Next, it reduces the hallucination. What do you mean by this hallucination? Hallucination basically means your model is giving incorrect or misleading. Of course, you guys must be known to these terminologies, correct? Or which is a completely made up, which is a completely made up output, or a description which is given by your model. Okay, that is nothing but your hallucination. So in every field, in the field of finance, it may be in the field of medicine, or it may be in the field of law. So there is a possibility of this hallucination, that when it comes to finance, correct? uh, when it comes to your general model, it might give a wrong prediction on the stock prices, correct? That is why we fine tune it in on a particular data set, correct, to get the real information of the market. When it comes to medicine as well, we have seen there is something called as BioBird, correct? When it comes to finance, we've seen Finbird was there, correct? So it might suggest you some wrong treatments, correct? Wrong prescription, or wrong medicine details it might give you, correct? So when it comes to your fine tuned model, we will have a review it with the doctors as well. Whatever the data is given, whatever the output is given by the models, we'll review it with the doctors as well. And most of the time, again retrained on the multiple based on multiple data based on the doctor's suggestions and all. Okay, and then under the law also we have a specified model, correct? Legal bird was there, correct? Over there also there is a possibility it might give you wrong information or a misleading information about the charges applied on a particular accused for a particular crime or something like that. There are many sections when it comes to the law as well. Yeah. So we will basically reduce the hallucination. Then domain adaptation for industries. Of course, we understood from so far we understood that on a particular domain we can make our chat GPT train, correct? So when it comes to the customer support, instead of giving a generic reply, what we can do, we can fine tune this model, and for that particular company, what is reply needs to be given, or what is automated reply needs to be given, or what is a customized reply needs to be given, we will train for that data. Then legal tech, correct? Basically your general model, it misinterprets legal clauses. So We will train on multiple specified cases and all. We will train, particularly maybe all the criminal cases and the verdicts given on that, right? We will train on those data. Then cyber security. Maybe so far your general model will fail to detect any kind of new threats or new cyber security breaches, correct? Or data breach or whatever it is, it won't be able to detect it. But when it comes to your uh, fine-tuned model, it will be able to detect it, what is happening exactly with your system or with your data. Okay, and it will give you alert that there is a breach with the logs or whatever it is. Yeah. Now let us see how does this fine tuning works. Okay, let us have a basic overview of it. Over basic, what is the basic process we follow to fine tune a model basically. So we will start with the pre-trained model. We will take either GPT, either BERT or the T5, or we have multiple models. Other models are there, right? So we have Llama, multiple models are there. So we will take that model, and what we will do, already which are being already pre-trained on all the most of the general data, correct, which are being pre-trained in most of the general data. So once we take that model, we will provide task specific training data, maybe which is related to medical sector, finance sector, legal sector, correct, whatever the sector we are working in. So we will train our model based on that. Okay, then train the model using supervised learning techniques. Okay, we will provide the new data, correct. We have multiple supervised learning techniques as well. We can do the anomaly detection with that, correct. We can predict the data with that, correct. We can use that. So train the model using the supervised learning techniques. Then optimize performance with hyperparameter tuning and evaluation, correct. We will do hyperparameter tuning. We will adjust batch size, we will adjust iterations, we will adjust epochs. Multiple parameter hyperparameters are there, so we will adjust all those hyperparameters. Okay, once it is adjusted and once we get a good results, when we are getting the good results, and we will deploy the fine-tuned model for domain specific task. Once we got that, once we understood that yes, we are getting a very good results, then we will deploy our model for the user specific task or the domain specific task. Now let us see what are the different levels of fine tuning we have. It is not only like we will just provide a new data and a new domain specified data and it will start working. No, it is not like that. We will see what are the different levels we have. That is, one is fine tuning can be full. That means entire model is being fine tuned. Whatever the general understanding you had, right? You are just removing all those things, and from the beginning, you're starting. Okay, from the beginning, you start to train the model. Okay, then comes your partial. Okay, what you do, you freeze some sort of layers in the model, or it is also called as parameter efficient. Okay, parameter efficient. Okay, so when it comes to, let me give an example and explain you this. When it comes to completely fine tuning your model, basically what happens, you are retraining an athlete. Okay, you are retraining an athlete. Maybe the athlete was in the break for some period of time. So what you need to do? You need to retrain from the beginning. Maybe changing their diet, correct? Changing their diet and maybe workouts or some other techniques. Okay. So training from the beginning, from the diet, you start to train the athlete. So that is nothing but your full training. Okay, training the entire model. Next comes your partial training, okay, or freezing few sort of layers. That is, we are retaining some general knowledge. Okay, whatever the training is being done to the model, pre-training, right? We are retaining all those things, and then upon that we will add few layers. Upon that we will add few layers, a domain specific, so that we do a domain specific task. Okay, and then comes parameter efficient. Okay, in this we have LoRa basically means low rank adaptation. low rank adaptation Low rank adaptation. And we have one more thing called as uh, adapters layers as well. Okay, we will see this specifically what it does. Basically, we are modifying only small portion of the model. We are modifying some small portion of the model. Some small portion of the model. So we understood what are the different levels are there when it comes to fine tuning. Now, let us see what are this parameter efficient fine tuning. What are the multiple layers we have, correct? What are the multiple layers we have? One is this LoRa. We also call it as low rank adaptation. Low rank adaptation. What is this LoRa? Basically, LoRa is of course, it is a fine-tuning technique, correct? It is a fine-tuning technique on LLMs, basically, which uses less memory, and computational resources. Less memory and computational resources. So why do we need this LoRa? What is the necessity of it? Basically, this LoRa, it modifies all its parameters, correct? So what happens in the full fine tuning? It basically modifies all the parameters, modifies all the parameters of the LLM, correct? Which requires a lot of memory, lot of GPU power is required, correct? But when it comes to the LoRa, we make only small changes. We make only small changes in the model. Okay, instead of updating or changing everything, we just make a very small changes. Okay, so let me give an example for this as well. Okay, let me give an example. Consider you want to you bought a new house, okay, and you don't like the color of the walls of that house. Okay, what do? Instead of repainting the entire house, you will just change the wallpaper, or you just add a wallpaper over there, correct? You just add a wallpaper to that wall. Okay, you just add a wallpaper to that wall. Instead of repainting the entire house, you just add a wallpaper to that wall particularly, correct? So that is nothing but your LoRa. And how it works basically? It basically freezes. It basically freezes your original model or the original weights. Okay, it freezes the original models and adds some trainable layers. Okay, it trains low rank matrices. Okay, so this is nothing but your LoRa technique. Okay, so in the chatbot improvement also we can use this domain specifically. Whatever the data you want to give, you can give it to them. Okay, so when it comes to LoRa, understand this, the model's core knowledge is not being modified. Okay, the model's general knowledge, whatever it is being pre-trained with, it will stay as it is. Added to that, we will give some extra information for the domain specific tasks. Okay. Then comes your prefix tuning. What is this prefix tuning is? It is also a lightweight fine tuning technique. Okay. A lightweight fine tuning techniques that improves a pre-trained language model's performance on a specific task without changing its main parameters. Without changing its main parameters, it will it will change, it will modify few things in your model. So let us understand this also with an example, how it works maybe. Consider you want to write a book, correct? You want to write a book. Instead of rewriting the entire book, that is nothing but your full training, correct? Full fine tuning, not full training, full fine tuning. Instead of rewriting that entire book, what you do, you just add a short introduction or notes before each chapter. Okay, before entering to each chapter, you add a short notes short notes. Okay, before, as the name says, prefix, correct? Before entering, before doing any, before writing, going into any specific chapter, you just add a short notes of it. Basically, you give a brief of the whatever the whole chapter contains. All those details are given in the short notes. That is nothing but your prefix training. That is nothing but your prefix training. Okay. So how it works basically? How it works? Okay. So your model will not be changed. In this case also, your model will remains unchanged. Okay. A small prefix is added. A small prefix is added before the actual data, before the actual input of the data, we will add a small prefix data, which will make your model more understand what is the specific domain that your model needs to concentrate on. Okay. Uh, Maybe medical diagnosis chatbot. When you give a prompt, right, you might write it as a summarize this patient's diagnosis in simple terms. So it understood that this is something related to medical field, correct? So only based on this prefix, whatever the prefix you will give, it will be trained more, so that it makes your model more fast and efficient. Okay, this is something with respect to your prefix tuning. Now let us see the third technique, that is adapter layers. What is this adapter layers? So adapter layers are, it is also a lightweight and efficient fine tuning technique. Okay, it is also lightweight and efficient fine tuning technique that allows your LLMs to be adapted for new tasks without changing the main model parameter. Okay, what it will help in for new tasks without changing the main model parameters, without changing model parameters. Okay, instead of changing the entire model, which we do in full fine tuning maybe, okay, we will add a small trainable layers. You have multiple so neural network, right? You have multiple layers like this. This is an input layer. Okay, so what you do, you just add a new layer over here. The dense network, consider it as a dense network. Okay, you will add a new layer over here. You will add a new layer over here. Okay, like this, you will add a, you will connect each neurons basically. You will add a new layer over here, which will finally will go to your output data. Some output you will be getting. Okay, some output you will be getting. Basically, you'll add a new layer to the your entire model layers, already existing model layers. Okay, so let us speak this also with an example how it works. Okay, so maybe instead of you don't like the maybe there is no space in the house. Okay, there is no more space in the house. So what do? Do you destroy the entire house and start rebuilding it, or will you add an extra room to it? Attach a room, you will attach a room to it, you will build a room to it attached to your house. You will go for to build a room, right? If there is a shortage of the space in the house, so that is nothing but your adapter layers. Okay, you will add a layer to your already existing layers of the model. This is nothing but your adapter layer. Okay, these are the few layers what we have discussed. Then what are the challenges we face in fine tuning? Basically, data scarcity. Small data sets lead to poor generalization. We need to provide a lot of data to it, correct? We need to generate data, or we need to use some synthetic data so that we can overcome this data scarcity. Then comes the overfitting. Model memorizes instead of generalizing. Your model starts to memorize the whatever the input data you have given for a specific domain. That is one of the challenge what we face. And then compute cost. Okay, it is quite expensive because uh, you might need to spend some money on this techniques whatever we discussed so far. Yeah, when it comes to the summary, we learned about what is the difference between fine tuning, uh, hyperparameter tuning, and the pre-training the model, correct? And we learned what are the different what type of a task it does, and then what are the advantages of doing fine tuning. When it comes to it, it reduces the hallucination, it improves the domain specific performance. We need also choose a right fine tuning methods as well based on our requirement. So that's it. That's a brief idea about the fine tuning. Thank you, everyone.